Okay, so let's quickly look through task 3.4. Slide 19 and 20 were opportunities to graph. And the way we graph is by starting by plotting the roots, determining the multiplicity, which that's a new word, so we'll talk about that in just a sec. And then sketching the correct end behavior. So we're kind of putting all the pieces together, guys. We talked about end behavior last week, and we haven't actually used it for anything except being able to state the end behavior. Friday's task was bringing that together for a little bit more of a useful purpose. So here is slide 19. I know some of you guys got a chance to do slide 19, but for those of you guys who didn't, a lot of you were questioning how to know how to sketch, how to plot the x-intercepts and so forth. That's what we're going to practice. So right here, each one of these factors gives us an x-intercept. Each one of these factors gives us an x-intercept. So this first factor gives us the x-intercept of x equals 0. So we're going to plot right here at 0. This next one gives us the x-intercept of x equals -1. So we're going to plot right here at -1. So I had said first we find the x-intercepts and plot them, then we check their multiplicity. Oh, Jillian, great question. Because if I were to think of this as a factor like x minus 0, that kind of helps me visualize, okay, that actually is 0. Also, if I were to just plug 0 into the equation, so if I were to take 0 and substitute 0 in right there, that would multiply to everything and make it 0. So when we don't add or subtract to it at all, that is an x-intercept of 0. Okay, so now that we have our two x-intercepts, we have to think about, well, these two x-intercepts, how are they going to behave? That's this word multiplicity, and we will keep talking about multiplicity. How are they going to behave? Well, this one right here has just a first power, so that one's going to behave like a linear function. It's going to pass straight through. It's going to pass straight through the x-intercept. This one, because it's got that cube right there, that x to the third, that's going to behave like a cubic function, meaning it's going to pass through with this kind of swivel, what we'd normally expect from a cubic function. We're not worried about the 1/2 yet because all we're focused on is our x-intercepts. So we don't have to worry about that 1/2 quite yet. All we're focused on is our x-intercepts. So I know that this guy right here is going to have that little swivel, and this guy right here is going to go through in a straight line. But before I can actually connect those, now I have to step back and look at the whole function. So when I step back and look at the whole function, what is the total degree on this? Meaning when I multiply the whole thing out, if I were to multiply this whole thing out, what would be my total power on the x? Well, if we kind of step back and look at our function, x to the first, this will eventually, when we multiply this out, be an x cubed plus a bunch of stuff. So that means x to the fourth is going to be our full power. When I think about what an x to the fourth function is, well, an x to the fourth function looks like a w. It can have some weird oddities to it. It can be kind of lopsided, but it looks like a w. Now is where we look back at that 1/2 and we say, okay, that 1/2, is it positive, meaning we're still facing upward? Or is it negative, meaning this whole entire w, this whole entire quartic function is going to flip upside down? And that's where we see that it is in fact negative. It is in fact negative. So instead of us seeing this upward facing w or upward facing quartic function, it's going to go downward. So I know these two ends, sorry, that wasn't amazing. These two ends have to go downward. Those two ends have to go downward because my ultimate end behavior has to be down and down. So now I just have to figure out how to work around that. Well, right here, I know that it's got to, let me give this a little more detail. I know that it's got to kind of approach with an inflection or a curve and leave with that curve. And here it's just got to go straight down. So that would be a way to sketch this graph. Now when I'm looking back at it, I say, is it satisfying what we see in the equation? Well, we do know it's an x to the fourth, so it is down and down on both sides. That fits. It's a negative x to the fourth. That's why it would go down and down, not up and up. I see that it has one x-intercept at 0, one x-intercept at -1. That x-intercept at 0 passes straight through like a linear or straight line, and that x-intercept at -1 passes through with a swivel or an inflection because it matches that x plus 1 that is cubed. Okay, so that is slide 19. Questions before we look at slide 20? Okay, let's check out one more example, slide 20. I will post these, by the way, after. I'm erasing it now just so I'm able to practice it once more with the next class period. Slide 20. Let's start by just tackling each individual piece of it. So right here, we have an x-intercept at x equals 0. So let's plot it. Right here, we have an x-intercept. This one's tricky, so I'm actually going to write it out. Does the line between the 2 points have to be specific? Let me answer that in just a second, Riley, okay? I'm going to subtract 1 from both sides, divide both sides by 2, and there we go. That's where our x-intercept is. It's at -1/2. So actually, I'm going to change the scaling on this. I'm going to make this scaled. That's 1. That's -2. That's -3. Just so we can see this in a little bit more detail. Okay, so we have our x-intercept at 0. We have x-intercept at -1/2. And then this last one is an x-intercept at 1. Okay, so thumbs up if you know how to identify the x-intercepts and be able to just plot them right on the x-axis. Riley, question or just a thumbs up? Okay, cool. So now that we have those, let's kind of indicate how are they going to behave. Well, this one is kind of an x to the first power, so this one is going to pass straight through. This one is x squared. Well, x squared means a parabola, so this one's going to kind of make a parabola type shape. And this one is also x to the first power, so this one's going to pass right through. That again is called multiplicity. Do we have any multiple roots? And you see we did have one multiple root, that one of them was squared. So before we go ahead and start to sketch this, because a lot of you guys are having trouble with the general sketch, we have to figure out what's the total degree. What's the total degree? So if this is a first degree, this is a second degree, and this is another first degree, we once again have an x to the fourth. We once again have an x to the fourth. So that means we're going to have that W shape. But I'm asking myself, is that W shape facing upwards because it's positive in the front, or is that W upside down because it's negative? And if I look right here at the very front to see what our leading coefficient is, there's no negative there. So it is going to be this kind of upward, where it has to go up on this side and up on this side. So I have everything I need to graph now. I know which direction everything needs to go in. That quartic tells me it has to be up and up. I know what to do at each x-intercept. The first x-intercept, as we indicated, is going to pass straight through. The second x-intercept is going to bounce off or make kind of a parabola type shape. And the last x-intercept is going to pass straight through. So this is where I think the question was, am I concerned with what goes on in here? Like where these points exactly go, how steep this is, where to plug in? No, I'm not. I'm not concerned with those at all. All I'm concerned with is that don't erase. All I'm concerned is that this one passes straight through. This one bounces off to make that kind of parabolic bounce, and that this one also passes through. If you were to plug in points, you would find that both of these go like much deeper. For now, that's not what we're doing. We are just sketching. And from our sketch, we can see really clearly the x-intercepts and the end behavior. So that's our focus, the x-intercepts and the end behavior.